Hello everyone, myself Gautam Engineering. I'm studying in Industrial College of Engineering, third year, currently pursuing fifth sem in CSC department. Today I'm here to do an video assignment based on a topic machine learning based packet switching methods for providing stable high quality video streaming in multi-streaming transmission, which is which is a part of the computer networks based on the topic packet switching. So in this research paper, we are going to know how the packet switching comes into the play. Abstract. In the in the broadcasting gateway, equipment generally does method of simply switching to spare input stream, where when the fail occurs, the main input stream is unable to display. So here we are using the transmission and environment, which is unstable, and it faces the problems such as reduction of the lifespan of the equipment due to the frequent switching and interruption. It causes it causes the delay and challenges. These are the challenges we are facing through the broadcasting when we are live streaming. So how we are using packet switching method, which will help us to overcome this by applying machine learning method, which is possible to automatically judge and classify the network related services anomaly and switch multi input signals without dropping or changing signals, and predicting the quickly determining the time of error occurring the smooth stream switching when the problems of transmission error occurs. So in this way using the ML learning, and we can predict the transition occurs, and we can switch the streaming, so it helps us the smooth streaming way. In this way we are able to overcome this problem. Introduction. Broadcasting and communication technologies, which has been developed rapidly in the market, and the large capacity and high quality videos are provided in the user various forms. With the advancement of network processing, data is switched systems is transmitted over the network frequently. While it creates a significant impact on the system performance and data transmission, but not efficiently. The demand for this is the seamless and stable services while we are broadcasting the live streaming for 4K and 8K ultra definition content in increasing. So, providing content with the large capacity and high quality only through a terrestrial broadcasting network, there is a certain level of limitation in satisfying the users. Moving on to the related works. In the multi-stream technology, based on the broadcast communication, the transmission and reception of the broadcast signals based on analog ends and various technologies for transmitting and receiving broadcasts such as digital and being are developed. Compared to existing analog broadcast signals, digital broadcast signals include high quality video and audio, and additional data and the data. So broadcasting system transmits higher capacity and higher quality content than before, builds the redundancy to prevent broadcasting accidents, switch the users to transfer broadcasting signals when the error occurs. Switch in literature review. Switches in the existing broadcasting system, which is configured as MPE32 transport system, since the advent of the Advanced Technology System Committee Standard 3.2. The digital broadcasting method, it's essential to develop and build an PI based switch to which ATSC technology applied. The suite of the voluntary technical standards and recommended practices for fundamentally which are different. So, the higher capacity to deliver UHD services and the robust reception on a wide range of devices improves the efficiency of the IP transport and advanced emergency alerting, personalization features, and interactive capability. As per ATSC 3.0 standard provides the more capability than the previous generation of terrestrial broadcasting and ATSC 3.0 system in designing with a layered architecture due to many advantages in system, particularly in upgradability and extensibility. So here is a diagram how the ALP and AP and TP and SLP TP are going through this. See here in the IP analysis and ILTTP analysis, SLTP analysis, which is going to a seamless switching model where the IP analysis, ALTP, both both are going to seamless switching model. Then it goes to FEC generator. Then it finally gives to the APLTP and FEC. So here is a ATSC flowchart where ATSC 3.0 switch which connect with the multiplayers and it gives to the gateways where the gateways in turns to switch the switch are transmit the switches are enables to allow the frequencies through the transmitter where the two different towers where both the frequencies matches overlaps and the areas is called SFN application. In that particular area the application is applied. Data analysis and findings. Transmission technology based on ADSC and 3.2 based on the broadcasting gateway equipment and transmitters. It builds as a form of single frequency network which is known as SFN with several transmitters and connected to the broadcast gateway. The broadcast gateway equipment receives ATSC 3.2 link layer protocol ALP packets through studio reference and output based packets through the studio transmitter interface. In this process, as we seen above the diagram, here how the transmitter, how that a switch, ATSC switch, which connects, which gets the input from the multipliers and it gives to the gateways, and from the gateways to the transmitters, and transmitter which emits the frequency when the two frequencies overlap, then we are going to create that frequency overlap area. So in this in the as per as we discussed in the above diagram, the delivery format, the standard internet protocol which is RTP, UDP and ITP, either of this to enable the input and output through Ethernet cable. So the LP stream analysis module and the SLT stream analysis module are required to detect an error of the packet stream incoming through. So if any error packet is coming through this network, coming through the from one layer to another layer, so it can able to predict, and so we can able to replay switch the stream to avoid the errors to continue the smooth streaming. Here are the studio infrastructure, system manager, and the studio entities where interchanges with the broadcast gateway and which moves on to the SNF single frame networks or transmitters, and it goes on to the over air which broadcasts. So this is how basically it works, and the CPU usage, how it is how it has been utilized. The references such as YN Jan, YN Zia, CLN when quantize stabilization of switches system with switching delays and packet loss. J. Frank NST. Gota, Yoshinoki, Takunachi, Makawa. The method to reduce the interruption time streaming. These are the references where this research paper has been taken. Finally, the conclusion. Finally, the conclusion. As broadcasting communication technology has developed various problems and limitations, multi-stream changes, and simultaneously use the terrestrial broadcasting networks and the wired, wireless with high speed provide large capacity and quality content to the service without interruption has been recognized. So to overcome this problem, in this research paper, we have presented a smart packet switching method for maintaining the stable high quality video streaming in a multi-streaming transmission environments using machine learning and cosine similarities, where it can predict or detect the errors which are about to occur. Then it will replace with the another stream where the smooth where the online streaming will occurs without any kind of error smoothly. So this by using the main packet switching method principle. Thank you. Have a nice day. Please do like, comment, share and subscribe.